Velocity as a function of time. Speed is a scalar quantity which has magnitude only. So for speed, we will only take positive answer. Whereas for velocity, it is a vector quantity which has a magnitude and a direction. So the answer for velocity may be positive or may be negative, depends on its direction. The definition of speed is the rate of change of distance with time. This is the formula of speed, distance over time. So the rate of change of distance with time. Whereas for velocity, the definition is the rate of change of displacement with time. Later on, you will learn that velocity is actually ds dt. So it is the rate of change of displacement with time. Okay. So if O is a fixed point and the movement of a particle to the right is positive, then when the question mentioned the particle moves to the right, we will write v greater than 0. The velocity is positive. When the particle is at rest, that means the particle is stationary or stops, or when they say the particle changes direction, then v will be 0. Because when you change direction, for sure you have to stop for a while, then only you can change. So at rest, stops, or change direction, or this also, we have v equals to 0. When the particle moves to the left, we have v less than 0, velocity negative. Okay, so let's do a quick revision. Previously, we learned about displacement. They are different. When we talk about displacement, when the particle is on the left, s less than 0. Moves to the left, v less than 0. On the right, s greater than 0. Moves to the right, v greater than 0. Okay, on point O, s equals to 0. Stops, v equals to 0. Okay, I hope no problem. Okay, next one. Instantaneous velocity means the velocity of an object at a certain time. That means, for example, when they ask you to find the instantaneous velocity when t equals to 5, means you just have to substitute t equals to 5 into the velocity equation. That means you get the answer of velocity when t equals to 5. Okay, next one. Uniform velocity means the change of displacement of a particle is the same for every unit of time. That means, for example, let's say for every second, the particle moves 2 meters to the right. That means the displacement of this particle is the same. Okay, for every second, for every unit of time. Then we say the particle has a uniform velocity. When the particle has a uniform velocity, the acceleration is 0. We will learn this later on. Velocity can be determined by using the number line and the gradient of tangent at one point on the displacement time graph. Let's check one example. A pupil is running along a straight track from a fixed point O. His displacement is given by s equals to 8t minus 2t squared, and the displacements from t equals to 0 to t equals to 6 are recorded. Okay, you want to draw a number line later. So first of all, you can draw a table like this and label your value of t from 0 until 6. And then this is the displacement equation. We just need to do substitution. When t equals to 0, substitute into the displacement function, we have answer s equals to 0. When t equals to 1, substitute, we have answer s equals to 6, and so on. Okay. Later, from the number line, you also can label the answer for velocity. So now you also can do a small step to identify the velocity function. So when you are given displacement function and you want to find velocity, you can do differentiation. So differentiate 8t, answer 8. Differentiate negative 2t squared, we have answer negative 4t. So we do the same thing. When t equals to 0, we substitute inside. We have answer v equals to 8. When t equals to 1, we do substitution. We have answer v equals to 4, and so on. Next, we also can draw a displacement time graph based on the value here. First of all, let's check the equation. s equals to 8t minus 2t squared. So from here, we notice that this is a quadratic equation with a equals to -2. That means a is less than 0. That means when you want to draw a displacement time graph, you need to draw an N-shaped parabola. Let's check these two rows. When t equals to 0, s equals to 0. When t equals to 2, s equals to 8. When t equals to 4, s equals to 0. And when t equals to 6, s equals to -24. So we have a displacement time graph like this. And from the displacement time graph, we can identify the value of velocity. So let's check. When t is in between 0 to 2, let's say we have a point here. When you want to draw a tangent line for this point, we notice that this tangent line slants to the right. Tangent line slants to the right means differentiation greater than 0. This equation is s equals to 8t minus 2t squared. When we do differentiation, we have ds dt. ds dt greater than 0, that means v greater than 0, because ds dt means velocity. So we identify already, when t is in between 0 to 2, velocity is positive. And the meaning for velocity positive is the pupil is running to the right. Okay, next one. When t equals to 2, let's say the point here, the maximum point 2, 8. When you want to draw a tangent line, we notice that the tangent line is a horizontal line. That means when you do differentiation, we have ds dt equals to 0, means v equals to 0. Okay, that means we identify at t equals to 2, v equals to 0, which means the pupil is at rest. Okay, next one. When t is greater than 2, let's say you have a point here, and when you want to draw a tangent line, we notice that the tangent line slants to the left. That means ds dt is less than 0. And ds dt means velocity, means v less than 0. So we identify already when t is greater than 2, velocity is less than 0. And the meaning is the pupil is running to the left. Example 9. The velocity of a particle is given by v equals to t squared minus 8t plus 7, where t is the time in seconds after passing through O. Find the instantaneous velocity in meter per second of the particle when t equals to 3. So we see the word instantaneous again. Instantaneous velocity when t equals to 3 means ask you to find the answer of velocity when t equals to 3. So we just need to do substitution, sub t equals to 3 inside. Then we have answer v equals to -8 meter per second. Okay, next one, B. Calculate the values of t in seconds when the particle stops instantaneously. When the particle stops, v will be equals to 0. So v is t squared minus 8t plus 7. We let it be 0. And then let's do factorization. Then we have two answers for t equals to 1 and t equals to 7. Because both answers are positive, so we accept both. Okay, next one, C. Determine the range of values of t in seconds when the particle moves to the left. Okay, we have already learned the concept. When the particle moves to the left, means velocity is negative. So that's why for this question, we put v less than 0. Okay, so t squared minus 8t plus 7 less than 0. We do factorization, t minus 1, t minus 7 less than 0. And since this is a quadratic inequality, so please do graph sketching method or number line method. Graph sketching method is easier. So I draw a graph like this. The x-intercept is 1 and 7. And then we check less than 0. Less than 0 means the y-coordinate less than 0. That means we have to choose the graph that is below the x-axis. Okay, so that's why this is the region that we choose. And then we read the region. Answer is t is in between 1 and 7. Example 10. The velocity of a particle is given by v equals to 3t minus 12. Calculate the initial velocity of the particle. So whenever we see the word initial, means t equals to 0. So they are asking you the answers for velocity in the beginning of the experiment. So we just have to sub t equals to 0 into the velocity function. Okay, then we have answer v equals to -12 meter per second. Next one, calculate the instantaneous velocity of the particle when t equals to 5. So we just have to substitute 5 into the velocity function. Then we have answer v equals to 3 meter per second. Next, calculate the time in seconds when the instantaneous velocity of the particle is 6 meter per second. So they give us v equals to 6 and ask us to find back t. So v equals to 6 and the velocity function is 3t minus 12. So 3t minus 12 equals to 6. Then we just do algebra. Then we have answer t equals to 6. B, sketch the velocity time graph to represent the movement of the particle for t in between 0 and 6. So let's check the equation. V equals to 3t minus 12, v power 1 and t power 1. So this is a linear equation. For linear equation, when you want to draw a graph, it will be a straight line. Okay, then let's check the range given, 0 and 6. So you have to find the answer. When t equals to 0, what's the answer for v? When t equals to 6, what's the answer for v? Okay, then let's check what we had just now. This is a velocity time graph. The x-axis is t and the y-axis is v. So just now we have 0, -12. And then 5, 3, 6, 6. Okay, 0, -12 is the beginning of our range. And then 6, 6 is the end of our range. Okay, usually after we plot the beginning and the end of the range, we also need to plot the y-intercept and x-intercept. So for y-intercept, no problem. -12 is the y-intercept. So to play safe, please find the x-intercept as well. At x-axis, y equals to 0. That means at t-axis, v equals to 0. This is 3. So 3t minus 12 equals to 0. We have t equals to 4. So that's why I also label 4. This is the x-intercept. So this is the velocity time graph.